where we did the independent t-test. We're looking at the paired t-test. Paired t-test sometimes is also called the dependent t-test, which is obviously opposite of the dependent t-test. So we're going to look at one parametric type of analysis and then one non-parametric. Okay, so really we're looking again at the differences between two related groups as opposed before where they were the differences between two unrelated groups. Okay, so the generic research question, if you're looking to answer, would be are the means for the parametric test or the non-parametric test, the medians of the two related groups different from one another? So the two related groups typically are the pre and post test, usually from a one group pre and post test design, which I'll show a little bit later in these slides. When they say match control, that just means that you take statistically, use some type of statistical procedure and portion out males or females or something like that. So. Okay, so we always have our grouping variable, and this more or less defines the two related groups that are being compared. And the best way to identify the grouping variable is usually when it's the pre-test or post-test time, or the person who's in the match control, which means we just know we're measuring the same person or the same individuals from one point to another and comparing those times statistically. Characteristic of interest, usually the best way to define this or conceptualize it is really it's the dependent variable. So it would be an interval or ratio variable. Sometimes they call it continuous, and like I said, it's a dependent measured at least 2 points in time, and it's got to be with the same group or individuals. Quick example, blood pressure pre-medication and looking at the blood pressure post-medication. Okay, let's look at some more clearer examples as we go here. Does a healthy heart education program increase knowledge about cardiovascular knowledge in teenagers? Okay, so let's kind of break down the question here. So we have our variables, our independent and dependent variables embedded within this question. We have education program, it's an independent variable, and we're looking at its effect on the outcome. Our outcome is cardiovascular knowledge. That would be our dependent variable. Okay, grouping variable in this case would be our pre-test, post-test, and then the dependent, like I said, was this operationalized by a score 100 on a cardiovascular health quiz, which is worth 100 max points. I included this just, I think it helps you understand visually what type of design, because remember I said the analysis always come after the design, so it's a bit hard to fully understand these analyses without understanding what specific type of design is being used, because again the design and the type of data drive the type of analyses. So in this case we're looking at a one group pre-test post-test design. If you see in the top left, the diagram shows the pre-test. You have observation point 1. You have the treatment. Treatment is also known as the independent variable. And then the post-test, observation 2. So in the bottom right, I kind of filled in the boxes here. So the pre-test, you take the cardio test. You receive the independent variable, the education program, or the treatment. And then the second time, it's all the same group. And as you see, time moves from left to right. So understanding that because you use this type of design, it would necessitate the use of this paired t-test or dependent t-test. Again, it compares the means of the two related groups. It is parametric, so you would assume remember your assumptions, that the data is normally distributed, and you'd be looking at the mean and the standard deviation between each group. Now, if the data were not normally distributed, and you would figure this out in your preliminary analyses, then you would look at the medians of each group, because as you know, if it's not normally distributed, then the mean would not be representative of the data. Okay, it wouldn't be an accurate representation. The median in this case would be more of an accurate representation of what's really going on within this group as a whole. And then you would use your Wilcoxon matched pairs test to compare the distribution of the median between those two groups. So let's ask a question. Paired data must always come from pre-test, post-test designs. And the answer is not necessarily. Paired data can also come from studies with cases and match controls, such as what you may see in twin studies. So let's go through the steps of computing the paired t-test. Like I said before in the previous lecture, that this is kind of more of a step-by-step hand calculation method of doing this paired t-test, where normally you would be doing this via SPSS or Excel or some other statistical software program. So we illustrate this test with data that came from 31 teenagers. The teenagers took the cardiovascular health quiz before attending a Healthy Heart program. Okay, took the quiz again after completing the program. So what this looks like is that, as an example before, the one group pre-test, post-test design, our dependent variable, which is the outcome, is the cardio quiz, and then our independent variable, our treatment, is the Healthy Heart program. Okay. So going back to our hypotheses, nulls and alternatives, null hypothesis, we're testing to confirm or reject the null. There's going to be no difference between the pre-test, post-test. Any differences we do observe are due to error. But our alternative hypothesis, there will be a significant difference, and it's going to be statistical significance. Not a significant difference in terms of magnitude, but we're just basically saying that there is a difference, and the differences did not happen by chance. We're not inferring that the differences are large. Okay, and this is non-directional. Remember, if it is directional, then we'd say in one direction or the other that they will have more knowledge or less knowledge or something like that. Okay, and remember, these hypotheses are derived from the original research question: does a Healthy Heart education program increase knowledge about cardio knowledge in teenagers? In SPSS, we can set the alpha level. Sometimes it's automatically set at 0.05, so we're assuming a 95% range under the curve, and we're giving around 5% for error. The critical value, you can look up in the T-table, but again, if you're doing this within SPSS, it automatically assumes and factors in the critical value from the T-table. Okay, so again, preliminary analysis and understanding what our assumptions are. You're looking at the two paired measures of the dependent variable. Okay, we're going to understand or look at and determine whether or not the data are normally distributed. Remember, if they're not normally distributed, then we would move to the non-parametric test and look at the medians, and that would, in this case, include the Wilcoxon matched pairs test. So looking at the visual display of the stem and leaf plot, we can determine that these are in fact normally distributed. Again, using descriptive statistics and putting them in the stem and leaf plot illustration. So these are the main descriptive stats that are entered into the equation. They are the mean and standard deviation scores. So just visually looking at this, it looks like there is a difference in score. Of course there's a difference when we look at it descriptively. So we look at the pre, it's around 70. They on average scored about a 69, and on average they scored about a 78 after they received the program on that test of 0 to 100. But now we need to run the actual t-test to determine, did these results happen by chance or not? And if we find out that they did not happen by chance, then we'll say our results are statistically significant. And again, I stress to you that statistical significance does not infer the magnitude of the differences. That is done through some type of practical significance, whether it be effect size or just visually understanding and looking at the descriptive statistics. This is always can make your eyes cross a little bit when you look at this. And again, this is the mathematic or algebraic equations that are undergirding this specific pair t-test. Of course, you would probably never sit there and hand calculate this. Some individuals do enjoy doing this, but for our purposes, it's not necessary. Typically, or specifically because your program, SPSS, handles these calculations for you. But this is really what's happening underneath these programs, okay? So now we need to determine statistical significance, and then of course we say our conclusion. Since the computed t-stat of negative 6.935 is smaller than the critical value, and if it were larger, we would conclude the same, that the difference in test scores from pre-test to post-test is statistically significant, okay? So overall, you might write it like this or state it like this: post-test scores on average of 9.03 points higher than the pre-test was significant or statistically significant at the 05 level. Can be concluded that teenagers in the sample had significantly higher test scores, and that I might have to add that it's not exactly accurate to say that they have significantly higher test scores. We're just saying that their test scores are higher and that differences that we observed did not happen by chance, okay? So the only way to fully determine if they are significantly higher is that if we understand the test and understand that actually a 9-point difference is substantially higher, and the only way to really know that is if you're an expert in the field and understand the test and understand that 9 points is higher, or perhaps 9 points isn't that much of a difference, okay? That's really the only way. The other way is to understand the effect size and use those means and calculate an effect size and determine through some type of practical significance that the magnitude of the differences were small, medium, or large. So let's consider the following question. A study compares calorie consumption in a group of 15 teenagers who are on a sports team with a comparison group of 19 teenagers who do not play sports. What type of data is this? And it's unmatched because, as you can tell, that the groups in one are not similar and are not related or are not dependent. So you might say they're independent of one another. In a match design, there would be the same number of participants in each group. We would be told what matching criteria were. It's an example of a study of an unmatched comparison group. And again, we haven't studied specifically designs or research designs, so getting into these details sometimes a little bit more difficult. But that concludes our presentation for Chapter 6.